Hi there, my name's Jack. I'm going to talk to you a little bit about two-way radio. Landmobile two-way radio. Two-way radio is often misunderstood. It seems like magicians, smoke and mirrors. And that is because we can't see, nor can we hear the actual radio frequency signals coming out of the aerial or being transmitted from the aerial. We can hear the audio coming out the speaker, all going well, and we can hear the audio going into the microphone. Somebody else adjacent to us might be using the radio, or we might be using it ourselves. So we can hear that audio, but we can't actually see nor hear the radio frequency signals coming out of and going into the aerial. Radio frequency signals behave a lot like sound and light. So there is direct transmission from one aerial directly to another aerial. There's reflection, so the signal is reflected off another surface. There's refraction, that's bending. There's diffraction, which, well, that one's tricky again. There's polarization. There's shadowing. There's blinding. So there's quite a few things that affect the way a radio frequency signal gets from one radio to another radio. Polarization is the one thing that has the biggest impact on how your radio system works. So in Landmobile radio we use vertical polarization. That's horizontal, that's vertical. You need to keep your radio vertical. If you've got it horizontal, at best you will notice a quarter of the signal is lost. I'll rephrase it. At best you'll notice a quarter of the signal strength. So that's 3/4 of the signal is lost. At worst, you won't hear a thing. You'll have total loss of signal. And if you've got your radio horizontal and you're actually pointing it towards the radio that you're wanting to receive the signal from, that's the worst case. So, polarization, we keep our radios vertical. Shadowing is best considered from a light perspective. A transmitting radio can be considered a light bulb. If you can see the light bulb or the glow of the light bulb, you'll have to picture it being nighttime, then you'll be able to communicate over the radio. But if you can't see the light nor the glow of the light, you're out of luck, mate. Blinding, I'll just talk a little bit more about this lighting and shadowing. So using a handheld in a car or a portacom building can be very problematic. The steel enclosure reduces the amount of radio frequency signal getting in and out. So the radio is often lying on the seat of the vehicle. It's not standing up, it's lying on the seat of the vehicle. So we've got two issues straight away. One, we're in a vehicle, we're in a portacom, so we've got less signal getting in and out because of the metal enclosure. And then we've got the radio lying down, and from the first thing I mentioned, which was polarization, we also know that that's a bad way to have the radio. So if you're in a vehicle or in a portacom, keep the radio vertical and try and keep it as close to a window as possible. You'll probably discover that in a portacom, for example, that the window on one side doesn't work as well as the window on the other side. And that's probably because the repeater is on the side of the portacom where the radio works best. Vehicle electrics and electronics can also create a problem. So if you're trying to receive a weak signal and you've got a computer screen or something like that running in a portacom, or in a vehicle you've got a fan, digital displays, all sorts of things in vehicles these days, lots of microprocessors, they can produce on signal or on-channel interference. And if you're trying to receive a signal which has been artificially attenuated, it's inside this metal enclosure, the car or the portacom, your signal level's down and there's something else making a signal on the actual frequency you're trying to receive, suddenly you've got crap again. So bear that in mind. You'll probably quickly, with that little bit of knowledge, realise by moving your radio around, oh yeah, that thing there makes a hell of a noise. So those are things to bear in mind. So some car windows have a high metal content as well, especially European cars, not certain on the American cars. A chap I know used to break car windscreens and put New Zealand replacement windscreens in them just so that GPS systems would work. So an in-car GPS wouldn't work, I think it was on BMWs. And the windscreens in these BMWs had a high metal content. And if you're wondering how does light get through metal, well, it does, but not necessarily very well. But let's broaden your horizons a little bit. I think it's a space shuttle, uses transparent aluminium for windows, so, and also fighter jets. So you can make metal transparent. What else have I written down here? Blinding. So blinding can be related to light and sound. If you consider that the weakest signal this radio can receive in terms of light is like the glow of a candle. And in terms of sound, it's like a pin dropping on the carpet. So that's the weakest sound it can receive. When it's transmitting, in terms of sound, well, it's like a jet engine. And in terms of light, well, it's probably brighter than a car headlight. So if you've got a radio that's trying to receive a weak signal, listening for a pin drop, or looking for the glow of a candle, when beside it is another radio that's transmitting on a different frequency, like a car headlight or like a jet engine, there's no way this radio can receive a weak signal while this one is transmitting a strong signal adjacent to it. The front end, or the receive part of these radios, is designed for normal situations, and that is not a normal situation. What else have I got written here? Well, one of the things that often happens with repeater systems, so the system's been well engineered and you're down in the car park and you're about to go out on your day's work and your mate Bob says to you, hey, my radio didn't bloody work yesterday. Okay, so you decide you'll test the two radios before you go. But you've got the radios pretty close together. Now, a repeater system uses you with your radio, and then the repeater itself has a radio for receiving your signal, and then it takes the audio or the digital signal from the receiving radio and passes it to another radio, a transmitting radio, and retransmits it. There's a fair bit of expensive filtering takes place, and then another radio out in the field receives what you transmitted through the repeater. Up at the repeater, that pin drop jet engine scenario, that candlelight headlight scenario happens, but there's expensive filters to accommodate the difference in signal levels and the difference in frequencies. When you've got two radios close together, you don't have that expensive filtering. So you're transmitting headlight, this radio is trying to receive a candle. It's not going to receive the candle because it's being blinded by the headlight. Well, it's not going to see the candle because it's been blinded by the headlight. It's not going to hear the pin drop on the carpet because it's being drowned out. The sound it's trying to hear, or the signal it's trying to hear, is being drowned out by the jet engine. So your mate Bob and you need to be about 20-30 metres apart and then do your testing. then you'll be able to check, oh yes, his radio works, my radio works, or maybe they don't. But if you've got them close together, sort of wasting your time. Alright, what else have I got? Microphones. This is a tricky one. So, I've got some Magic radios here. This one here is just a handheld radio. It's got a microphone there. It actually probably says mic. But it also has another microphone behind the belt clip, hidden in there. And the purpose of that is, this is the one I talk into. So going into this microphone is my voice and all the ambient noise. Going into this microphone is just the ambient noise. Hopefully, because I'm using the radio properly. So the radio itself then processes the audio from this microphone and the audio from that microphone. The noise part, the noise from this microphone and the noise from that microphone, they cancel out. So the only thing that gets transmitted out the aerial is my voice. Right. So how do we use these radios? Well, microphone, it actually does say mic, about 2 inches from your mouth, and talk across it. Testing 1, 2, 3, 4. When I take my finger off, you'll hear what I said.
Testing 1, 2, 3, 4. When I take my finger off, you'll hear what I said.
Told you the magic. Now, pretend that we don't know how to use the radio, and we talk like this into the radio, so I've got it quite a distance away, or we'll be very shy. We don't like talking into radios. I wonder what that will sound like. Can't hear a bloody thing. So, that doesn't mean the radio's shit. That means you're shit. Well, the person who trained you how to use the radio shit. Well, perhaps that's a bit harsh on them, but anyway, you understand what I'm getting at. So, talk across the microphone, normal voice, about 2 inches. There's a few other things that will affect it.
Talk across the microphone, normal voice, about 2 inches. There's a few other things that will affect it.
So, if you're familiar with car kits, that's using a cellular phone inside a car. Some people have Bluetooth car kits. Their cell phones pair to a Bluetooth car kit. If they've got the window down or the fan going, they probably don't hear what you hear when you're trying to have a conversation with them. And that's probably best. Hopefully I can demonstrate it with this radio. So the wind blowing across the microphone port definitely makes a noise, and that noise could be caused by, or that wind could be caused by a fan. It could be caused by the car window with a cell phone car kit. But if you're with a two-way radio out in the field and it's windy, or maybe you're sitting in an office and there's a fan blowing air right across you, nice and cool, it's also blowing that air across the microphone port. So you're probably going to be transmitting things you're not aware of. If you want a bit of training on that and you live locally to me, I live in Hastings, New Zealand, I can provide on-the-job training with my Magic radios. Not this one's pretty clever, but this one, it's magic. It's got a reel-to-reel voice recorder miniaturized down with a shrinking ray, and so everything that it receives, it retransmits. Okay, microphones, we've done that. What else we got? Will my radio work here? Well, that's another good question. Come back to that street light or that car headlight. Imagine the repeater's a street light. If you can see the street light glow at night time or see the street light directly, yes, your radio's probably going to work there. If you can't see the street light, if you can't see the glow of the street light, you might have to imagine it's night time because it's daytime when you're actually trying to use it. Then you don't have much chance of that. There's probably some things I've missed, but hey, we'll get into those another time. Something that immediately springs to mind as soon as I've said that is, how do you treat these things? These are your charging contacts for your battery. Before you drop it in the charger, give them a clean with a microfiber cloth, something like that. Just make sure they're dry and clean. Nothing abrasive, or nothing excessively abrasive like sandpaper or emery paper or anything like that. Just a microfiber cloth. You'll find that normally is the softness of that is normally abrasive enough just for cleaning these. So that's number one. Dirt, well, yeah, if that little wee hole gets filled up with dirt, I can demonstrate what that will sound like. Testing 1, 2, 3, 4, 5.
Testing 1, 2, 3, 4, 5.
Didn't work, eh? But anyway, if it gets dirt in it, it's probably not going to sound very good. How are you going to get that dirt out or that mud out? Let it dry and then brush it with a soft brush. If you go poking toothpicks or paper clips being folded out into that hole, you'll probably damage the protective covering on the Electroset microphone that's hidden behind the hole. And pretty good radio, eh, this one? You can block the microphone and it still works. Most radios aren't that clever. Alright, have a good day.